Hi everyone, I'm sorry if you had to miss our Monday or Tuesday class. Here's what we went over if you missed class or if you just want to review and see it again. So first we start off with the warm-up. Which of the following diagrams represents the solid, the liquid, and the gas? Number one was our liquid. My atoms or molecules, my circles, are rather close-ish together, but they're not actually touching. Some of them are. Actually, none of them are in this photo. Sometimes they can touch as a liquid, but they're pretty close together and they go from one side to the other side of the box. Number two is our solid. Those molecules or atoms, circles, are very close together. They are touching, they're very compact, very, very close together. It has its own shape. It doesn't go from both sides of the box. It has its shape that is independent from the rest of the box. So that is a solid. And then number three, those molecules are very far spaced out, so that makes that one a gas. Your homework, there's actually three different things that are due by the second class this week. First off is what is matter model 3? It is a continuation of the POGIL that we had last week. Last week you worked on 1 and 2 in your groups and then you finished on your own. This is just model 3. Again, on your own answers. You're welcome to work with another student, but your answers still need to be your own answers. Then you need to get 100% on the elements, compounds, and mixtures practice. Now, when you go to Canvas, it's going to say that it's a quiz, but it's actually going to be a homework grade. When you take the quiz, it'll give you back your answers. It'll tell you what you got wrong so that you can go back in and retake it again until you get 100%. I don't think this should take anyone more than like 4 chances. So that's why I want you guys to try and get 100%. And then your chemistry in the news, your current events assignment, there were slightly different names for it, is also due this week. So today we had a warm-up. We discussed the POGIL from last week, what is matter, how to organize matter, models 1 and 2. We took notes on how to classify matter, so you actually have some notes that you can go back and reference now. And then we talked about the asynchronous work just so you understood what you were expected. So here was our POGIL from last week. So I mentioned in my last video how to tell the difference between elements and compounds. So it kind of boils down to my elements only have one capital letter. Every time you see a new capital letter, you're looking at a new type of element. So NaCl, that N for Na is one element. The C for Cl shows you your next element is beginning. An element consists only of a single type of atom, so how would you define a compound? I would define that because compounds have more than one element. They are all bonded together, so they are connected. An element just has the one. Also notice that when I have a compound to show that they are bound together, I write all those symbols without any spaces, without any commas. It's like it's just one big word. How does a pure substance, element or compound, differ from a mixture? Mixtures are different substances. So a compound is different elements, but a mixture can be different compounds. It can be different elements. It can be compounds and elements, but they're all thrown together and they are not bound together. So a compound is different elements that are bound together. They're bonded. They're stuck together. A mixture, they aren't chemically stuck together. I can have salt on my soft pretzel, but that salt is not bonded to my pretzel. I can flick it off. I can pick it off. So it has to be chemically bonded together to be a compound. A compound is two or more different elements, and they're chemically bonded in a fixed ratio. So how does that subscript show us the fixed ratio? So I used H2O. That shows me that I have 2 hydrogens for every 1 oxygen. It has to be 2 hydrogens to every 1 oxygen. If I change that ratio, I get a new compound. So H2O is water. We need it to survive. If I were to change that, actually, I've got a good joke for this. Two chemists walk into a bar. The first chemist says, I'll take some H2O. Second chemist says, that sounds like a great idea. I'll take H2O too. Second chemist does not do so well. H2O2 is not water. H2O2 is hydrogen peroxide. It's one of those things you can pour onto a cut if you have a cut to disinfect it and it stings real bad and it bubbles. Yeah, that's not something we want to drink. So changing those little numbers, changing those ratios, gives you completely different compounds with completely different properties. Then circle which of the following are compounds. So CO2, those are all capital letters, 2 capital letters, so that's a compound. O2, you might want to say is a compound because it's got that subscript there, but there's only one capital letter, only the O, so that's an element. Fe, ooh, we got 2 letters, but the E is lowercase, so it's just an element. Fe is just iron. NaHCO3, nacho. That is definitely a compound. I have 4 different elements in that one compound. And then C8H18, octane. Again, I've got more than one capital letter, so it's a compound. Another thing is I have 2 different subscripts on that. Each element, each atom can only have one subscript attached to it. So the fact that there's an 8 and an 18 on that compound tells us that we're dealing with a compound. And then S8 is still just one element. Then on the next page, we were talking about different types of mixtures, heterogeneous and homogeneous. So homogeneous mixtures all look the same throughout. We don't always think of them as being a mixture. Most of us know that if you want to have some Kool-Aid, you mix the Kool-Aid powder with water to make your drink. It's a mixture. But when you go to get some Kool-Aid, you're thinking, golly, fruit punch Kool-Aid would really hit the spot right now. You don't go and ask your parent for, hey, can I have some Kool-Aid powder mixed with water? You go and ask, hey, can I have some Kool-Aid? You don't always think of things like milk of being a mixture, but it's a lot of different stuffers in our regular milk. Sprite, soda, we know that there are ingredients that goes into these things. That's not a revelation. But we don't often think of it as a mixture. We just think of it as its own thing because it looks the same throughout. Hetero does not look the same throughout. We can see the bits and pieces. So here it mentions a salad, cinnamon and sugar, trail mix. If I get a salad and it's got tomato and I don't want tomato on my salad, I can pick the tomatoes off. If I've got trail mix but I really don't like peanuts, I can eat around the peanuts. So I can usually pick apart heterogeneous mixtures and filter them pretty easily. It's kind of hard to filter salt water by itself. It's possible, but it's kind of hard to do that very easily. Now, the next 2, your answers will depend on your own life experiences, but red paint, homogeneous is the intended answer for that one. Homogeneous because when you go to paint something red, you typically want to have the same color red for that whole part of your painting. Lucky Charms cereal is heterogeneous because if I'm sitting down for a nice nutritious cereal breakfast, I can go ahead and pick out all of the, little marshmallows, all those lovely little marshmallows, and just be left with a good nutritious cereal left behind. All right, next consider the examples of aqueous solutions. What do they all have in common? So salt water, milk, Kool-Aid, Sprite, almost every liquid that you interact with is an aqueous solution that has water in it. Anything that we drink for the most part, anything that you should drink at least, is based with water. And also look at the word aqueous. Love those Latin root words. Aqueous, aqua means water. If you speak Spanish, or if you've been learning Spanish, agua is water in Spanish. Aqua comes from aqua. A lot of different languages have the same roots. So aqueous, aquaman, aquarium, aquifer, it all relates to water. So an aqueous solution is a homogeneous mixture that involves water. Next, it mentions that the air that we breathe is a homogeneous mixture. So it's roughly about a little less than 80% of it is nitrogen, N2. About 20% of it is O2, and about 1% of it is CO2, water, methane, perfume, farts, all sorts of stuff, all the other little gases that are in the air. So which of the three best illustrates what this looks like? The correct answer is number 1. So my nitrogen is that little black circle. So I have black circles connected to one other black circle. It shows me, that they are chemically bonded together. And most of the things in this box are that N2. Then I also have O2, so oxygen is that white circle. And I have a couple of those white circles stuck to each other to show me O2. And then lastly, I have other, are those triangles, so those are mixed out. Now you might be thinking to yourself, but Ms. Brubaker, I can see those bits. I can see the triangles. I can see the white molecules. I can see the black molecules. I can separate this out. Well, remember, this is a model of what's happening at the atomic level. So if you zoom out to what we can actually see, we can't actually see those individual molecules. Now, number 2 is wrong, and we can prove that number 2 is wrong, and that's definitely heterogeneous. That's showing the different molecules are organized. The nitrogens on one side, the oxygens are by themselves, and the others are off to the other side. If this happened in a room, you could only breathe like in one little square foot of your room. You could only breathe the air in your corner or in the middle of the room. If you stepped outside that, you'd only get nitrogen gas or water vapor. Let's not even talk about those other gases I mentioned quickly. So it's a good thing that our air equally mixes. And you can also see this whenever someone like sprays something that smells in a room, like let's go for a nice example, like perfume. It definitely hangs out in that area, but then it slowly travels to spread out into the entire room. And then that last one is very wrong. It shows them all bound together. You don't want these molecules all touching. You don't want those atoms all touching each other because that's not a mixture. A mixture is not bound together. You only want to bind things together who are in their same compound. So this is just a pure compound, really, is what's in this one, not a homogeneous mixture at all. So next, alloys are a special type of mixture where you take metal and blend it. So brass comes from copper and zinc being melted down and blended together. So does something that is being blended sound heterogeneous or homogeneous? Typically, when I throw things into my blender at the beginning, they're all separate items. I can see the difference. If it's a banana strawberry smoothie, I can see the bananas and the strawberries. Once I hit the blend button, it turns into a general pink color. I don't have bananas and strawberries anymore. I now have a smoothie. So it's homogeneous. And then if we look at what it looks like, copper is red, zinc is silver, but when I make brass, I get this gold color all around. If this was heterogeneous, I would have silver blotches and red blotches, but they come together to make one full flushed color mixture together. So this shows that it's a homogeneous mixture. Another great thing about brass, because it's made from copper, it is actually an antimicrobial surface. This is why a lot of us actually have brass doorknobs coming into our house or brass plated doorknobs coming into our house. Because if you were to sneeze on that, about 24 hours later, if nothing else touches it, those germs will be dead, which is really neat. All right, now we have a bunch of different examples. If you were in class, you either answered with your fingers or with a number in the chat, or today's classes, Tuesday's classes, I actually gave you guys polls to answer in. So apple juice, the intended answer would be homogeneous. When you're drinking apple juice, it's that same consistency all the way through. Now, some students say heterogeneous because a lot of times you need to shake the apple juice box or shake the bottle because it's from concentrate. Before you shake it, it is separated as heterogeneous. By the time you drink it, it's homogeneous. So that's why we wanted that for the answer. Helium is one of our elements. So the helium in a balloon, not the whole balloon system, but just the helium inside the balloon, is an element. 14 karat gold is actually one that I got wrong the first time, so don't feel too bad if you got it wrong. I wanted to say it was an element at first because gold is an element. But 14 karat gold isn't actually pure gold. 14 karat gold is some of the nicer jewelry that you can get, but it still has other stuff mixed in, like copper, maybe some iron. It's got a lot of impurities. So 14 karat gold is a homogeneous mixture. It's an alloy. Tap water. So a lot of people want to say that tap water is a compound. Well, if it just said water, that would be right. If it said pure water, that would also be right. Tap water, what comes out of your sink, is going to be a homogeneous mixture. There's a lot of electrolytes that are dissolved in your water. Now, most of the time, that's a good thing. The chloride, the fluoride, those are in our water on purpose for our benefit, but it's still a mixture. Next is soil. So it depends on your life experience what you think of when you think of soil. But when someone says soil, they mean like take a shovel to your front yard and get some of that dirt up. That's soil. That plant stuff, some pebbles, different types of dirt. It's a big, non-uniform mixture of stuff. Next, chocolate chip ice cream. If you really love those chocolate chips, you can dig in that ice cream and just try to eat those chocolate chips out. If you really hate chocolate chips, I don't know why you got chocolate chip ice cream, but you can kind of try and eat around them. So that is a heterogeneous mixture. Silicon dioxide, or SiO2, that is a compound. I've got more than one capital letter there. And then FeS is also a compound. I've got more than one capital letter. There's no spaces, so it is a pure compound. After we went over these, we started our new notes. So, turn that off. So if you go to our Canvas classroom, interesting. If you go to our Canvas classroom, you can go to our modules. At Student Copy of Unit 1 Notes, click on that. This link makes a copy of my master copy in my drive and puts a copy of it into your Google Drive. So you click on it and you see this, make a copy. Click yes, click on make a copy. So when you see it in your Google Drive, like I said, it's going to have a slightly different name. It'll just say Unit 1 Notes for you. You want to click right here onto this folder where it says Move. Yours will just say My Drive. That's where it currently is most likely saved. Click on this New Folder icon, and I would make a new folder named Chemistry. Click the checkbox and then click Move here because you want this PowerPoint presentation to be somewhere where you can find it later. Because if you click the link on our Canvas Classroom, it'll just make you a new clean copy of it rather than bringing you back to your current copy. Another note is that some students have asked to write this on paper, and that's perfectly acceptable. You're welcome to do whatever you like with this. You can print it out as a PDF and annotate on it with Kami if that's what you feel comfortable with. You can print this out on paper, put it in a journal, and write on it there. This is just a framework for your notes to make it easier to organize your thoughts. It's kind of like a textbook that's annotated or summarized just with the things that you need. So we skipped page 2 and we went right to page 3. So here you'd see a blank line. It's fill in the blank notes. So the first question is, how are the atoms or molecules or circles placed in the box? So atoms and solids are very compact, very close together. They're touching or just about touching. They're only ever found at the bottom of the box, and they're usually not touching either side of the box. In liquids, my atoms are close-ish together. They're not quite as close together as my solids are. when they're in liquid form. And then my gases, they are all over the place. They are very spread apart, and they're found all over the box. They are not constricted to the bottom of the container. They don't have their own shape. They take the shape of the container. Then to make these diagrams will not be on your class notes. What you do is you click on the circle, you hit Control C on your keyboard, click somewhere else, and then hit Control, and then press the V button a couple times to make copies of the circle. And then you can just click and drag it to fill it into your box. Then we went on to the next slide. Organization of matter. So your pure substances are only when they are elements or when they are compounds. Mixtures are two or more elements and or compounds that are not bonded together. Homogeneous mixtures are evenly mixed throughout, and heterogeneous mixtures are unevenly mixed throughout. So I had more circles to copy and paste to make examples here. Your pure elements can come in two different varieties. You can have the single elements, just the single dots, not touching anything else. And then you can also have them touching themselves. So it's orange dots only in this box, but it's orange dot bonded to orange dot. Because they're both orange dot, it is a pure element. Then the next box, we have pure compounds. I have different types of atoms, different elements. In this class, I made red, blue, and white. Notice I have red and white on the outside, blue in the middle. If I change that order, if it was red, white, and then blue, that would be a different molecule. It'd have a different composition. But I can have white, red, blue, white. It's just twirling around. Molecules do that a lot, actually. Then in my homogeneous mixture, I have white and green atoms floating around. They're not bonded to each other. They are not touching each other. This is a gas. They're very far apart. And it's evenly mixed. I don't have like a white section and a green section. I just have them all there together. Then the heterogeneous mixture, it is separated from each other. I have a green section and an orange section. They're in layers. They're not mixed together. So they're mixed together and that they're in the same box, but I can see there's a green section and an orange section. It's not randomly mixed in. Then if we had time, we went back to the second slide, and this is actually on your practice as well. If you have the sample of matter, your solid, liquid, or gas, then that solid, liquid, or gas sample is pure, or it is a mixture. If it is pure, then it's an element, or it is a compound. If it's a mixture, we have two different types of mixtures. We have homogeneous, or it can be heterogeneous. So you can use our notes that we took today in class to help you answer your homework questions. So in your elements, compounds, and mixtures practice, you have 14 different questions, 14 different samples of matter in boxes. Each question is going to have 3 answers. It's going to be a solid, a liquid, or a gas, elements or compounds only, or elements and compounds, and then it's either pure, heterogeneous, or homogeneous. So you need to choose one option from each of those 3 options. When you submit your test, it will automatically grade it since it's multiple choice. If you get anything wrong, it'll tell you what is wrong. So you're welcome to go back in and retake it as many times as you need until you get 100%. Now, it says that it's a quiz, and as far as Canvas knows, it is a quiz, but this will be graded as a homework, so it's really just a completion grade. So don't worry too bad about your grade. And then here is the PDF of the Model 3 Compounds versus Mixtures. It's a Kami assignment, so you annotate on top of it. I ask that you just use a text color that is visible and not black so your answers jump out and are easier for me to read. Remember, a teacher who can read your answers easier can see your right answers easier. Look at the models and answer the questions by looking at the models. So see, what do you notice? What patterns do you notice? And then your current events assignment is still due. Your current events in science and chemistry was assigned last week. And you were told you had a full week to get it in and finished. And so that is this Thursday or this Friday of this week. So don't forget about that. I guess that is all that we did in class today, all you need to be brought up on. I hope you make good choices and stay safe, everyone.